Hello class, today we're going to talk about multi-step inequalities. So let's review that by looking at a multi-step equation and going through the steps and processes that we used in order to solve that. If you remember correctly, on a problem like this we had 3 steps. Step number 1, get your letters on one side, and the majority of you like having your letters on the left. Step number 2, get your numbers on the other side. And again, for both of those steps we add the opposite. And at that point, we're able to solve. If we have a multiply, we do a divide. If we have a divide, we do a multiply. So let's see if we can remember what to do. First thing, I want to move the 9x over to be with the 4x. So I start at the equal sign, and I add its opposite. 9x plus negative 9x. And you'll notice here I've got a minus 12. So on the fly, and we'll change it plus negative 12 as I'm writing that. Okay, so you can change it in the problem, or you can change it on the fly like I just did right there. So this negative 9x is the thing that I added to the right-hand side, so I need to add that to the left-hand side as well. So 4x plus negative 9x plus 8. Now we put the like things together. So here we have a 4x plus a negative 9x. They can go together to make negative 5x plus 8. The 8 comes along for the ride. My 9s go away, and I'm left with a negative 12 on the right. Now we just have a regular 2-step equation. So now I need to move the 8 over to be with the negative 12. And again, we add its opposite. So negative 5x plus 8 plus negative 8. So the negative 8's the new thing, so equals negative 12 plus negative 8. Again, making sure that I add the new thing to both sides. And I end up with negative 5x is equal to negative 20. Now, I have a multiply by negative 5, so we do a divide by negative 5 to get x by itself, and you end up with x equaling, and then negative 20 divided by negative 5 gives me positive 4. So if I were to plug the 4 back into the original equation, we would show that both sides are equal. Okay. Now, what if I gave you this one? Now, this one's got a few more things in it. You'll notice over there on the right-hand side, we've got 2 x's. So before we do any math, as far as getting letters on one side or numbers on the other side, we need to put things together that we can. Okay, so this negative 3x plus 9, there's not anything I can do with that side, so I'll leave it alone. But my right-hand side has several things I can do. I can change my plus to a negative and the next to its opposite, and I can do that twice. You'll notice we've got a 7x and a negative 10x that I could put together. So 7x and negative 10x gives me negative 3x plus negative 6. And one of the main reasons why I change my minuses to plus is so that I can rearrange things, because we have the commutative property in addition, but not in subtraction. So now you should be noticing something. Okay, I'm hoping that you do anyway, and that you're remembering that if I've got the same exact variable on both sides, then something's going to happen here. Something's going to disappear. Okay, so let's see what happens. So I start here on the right. I want to move the negative 3x over to the left. So negative 3x plus negative 6. So here's the new thing. And then negative 3x plus 3x plus 9. And you'll notice we've got the negative 3x plus 3x on both sides, which means that my x's go away. And you end up with a statement that says 9 is equal to negative 6. Well, we know that when our letters go away, there's 2 situations we have. We have the statement that's left being false, or the statement that's left is true. And in this particular case, it's false. So when it's false, we cross the equal sign out because 9 is not equal to negative 6. And we say that there is no solution to this problem, because there's not a value, there's not a real number that I can plug into that x that will make this a true statement. Now, today what we're going to look at is multi-step inequalities. So you may end up with this same thing happening in an inequality. So we'll find out. Okay? So why do we do this? Well, the state of Texas says this. This is what we have to know. So 8.8a says that we've got to write one variable equations or inequalities with variables on both sides and represent problems using rational number coefficients and constants. So that means that we can use any kind of number that we want pretty much. That's a fraction, a decimal, a positive number, a negative number. We're going to have all of those. But we won't have real numbers, or won't have, not real numbers, won't have irrational numbers. We will have just the rational side of the real numbers as part of this. Okay, you will also write corresponding real-world problems when given a one variable equation or inequality with variables on both sides. So what I'm referring to on that is you will have any inequality given to you and you have to match it to the scenario. And those are the ones that are kind of tough for me. So I'm sure for some of you, it's going to be tough as well. And then model and solve one variable equations with variables on both sides of the equal sign that represent mathematical and real world problems using, again, here's that rational number stuff, rational number coefficients and constants. Now this one's mainly talking about equations, but you also have to do it with inequalities. Okay, and one of the types of models that you might see is a number line. Okay, so we'd have to be able to read the scenario and determine which number line actually fits that. Okay, so but today what I want us to do is just look at how do I solve multi-step inequalities. Well, same thing as always. We've got three basic steps. Step number one, get your letters on one side. Step number two, get your numbers on the other side. Step number three, solve. But this time when we solve, we got to kind of think, is my coefficient negative? If my coefficient's negative, we got to remember that our inequality is going to flip. So here we go. Let's begin. So we've got 3x plus 5 is greater than x minus 8. So I'm going to move this x over to be with the 3x. So I start at the inequality, just like I did with the equations. X plus negative x plus negative 8. And notice I changed that on the fly. So 3x plus negative x plus 5. Now we need to remember that this negative x, it is a negative 1x. So if I've got 3 x's and I have negative 1x, that's going to leave me 2x plus 5 on this side. Don't think that this x cancels out this x, because it doesn't. Okay, it's greater than. Now my x's here, they do cancel out because we've got a positive 1x and a negative 1x. That makes 0. Plus, oh, not plus there. Then we end up with the negative 8 left behind. So now I need to move the 5 over to be with the negative 8. So 2x plus 5 plus negative 5 is greater than negative 8 plus negative 5. Now just because I'm moving a negative across doesn't mean I flip the inequality, because my coefficient is positive. That's what determines whether or not it's going to flip. So 2x is greater than, and then negative 8 and negative 5 give me negative 13. Now I don't want to know about 2x, so I divide by 2, and x is greater than negative 6.5. And again, sometimes the answers will not come out nice. And that's how you solve multi-step inequalities. Okay, so if you'll notice, every single step was exactly the same as what we did with equations. So let's look at 2 more questions and then we'll be done with the video. So let's look at this one. Okay, so we've got 13x plus 8 is greater than or equal to 9x minus 12. So pause the video and you work it yourself for a few moments. Okay, let's see how you did. Okay, so I'm going to take this 9x and I'm going to move it over to be with the 13x. Okay, so I start at the inequality. 9x plus negative 9x plus negative 12. And then 13x plus negative 9x plus 8. Now we put together the things that we can. So I've got a 13x, and then we'll take away 9x's. So that leaves me with 4x plus 8 is greater than or equal to negative 12. Okay, so move the 8 over to be with the negative 12. So 4x plus 8 plus negative 8 is greater than or equal to negative 12 plus negative 8. So 4x is greater than or equal to negative 12 and negative 8 make negative 20. Then I divide by 4. Divide by 4. X is greater than or equal to negative 5. Okay, so hopefully you came up with that. Now let's see if we can try one that's a little bit more difficult. Because you know those standards that we had said that we could have any kind of rational numbers. So what if I gave you this one? Okay, this one I know some of you will immediately kind of cringe at this one because you see fractions. Oh my goodness, fractions. But fractions are just the same as any other kind of number. Okay, so you can leave them as fractions or you can change them to decimals if you want to. It's strictly up to you. I'm going to choose to leave them as fractions. So I want to move this 3/2, and that's how you would say that, over to be with a 1/2. So I start with the inequality. 3/2 m plus -3/2 m plus -12. Notice we do the same thing that we've been doing. Okay, it's just we have fractions. It's no big deal. 1/2 m plus -3/2 m plus 3. Okay. So now to put these fractions together, I have 1/2 here and I've got a -3/2. So if my signs are different, we subtract. 3/2 take away 1/2 gives me 2/2. Okay, so I've got -2/2, and 2 divided by 2 really is just 1. Okay, so this actually ends up giving me -2/2, which is the same thing as -1. So what we have is just -m plus 3, because that is the 1 in front of the m. Okay, is less than, and then on this side, my 3/2 m's go away, and I'm left with -12. Now I move the 3 over to be with a -12, so -m plus 3 plus -3 is less than -12 plus -3. So these 3's go away, and I'm left with -m is less than -15. Now, seeing if you remembered anything from yesterday's lesson. In yesterday's lesson we had a negative letter. And we found out that what we had to do, there was a -1 there, so we would divide both sides by -1. But we found that the trick to this was, I don't want to know about -m, I want to know about positive m. So I make -m its opposite with an m. And then I change -15 to its opposite, which is 15. And then I have inequality, and I change it to its opposite as well. So from less than, it turns to a greater than. And I'm sorry for that horn going off in the video there. That was class change bell. Okay, so when you divide through by that negative, we do flip the inequality. Okay, so let's try one more question, and we'll be done for the day. Always remember though, if you have a negative variable, the inequality is going to flip. So what about this last question? Last one that we're going to look at. Now this one should remind you of the warm-up that we had that was one like this. Okay, so we start by putting things together that can go together. So the left-hand side stays the same, but the right-hand side, my 2x and my 3x, can go together to make a 5x plus 6. Okay, so now you should be thinking, if I've got the same number on this side and this side, that they're going to go away. So if I were to add a -5x to both sides, I would end up with 9 is greater than 6. Now with an equation, with this problem right here, if my numbers were not true, if it made a false statement, you would say no solution. If it made a true statement though, you would say all real numbers. But with inequalities, what we have to look at is that statement true or false? Is 9 greater than 6? And it is. So this particular problem is all real numbers. Now if it made a false statement, let's say it said that 9 was less than 6, then we would say the answer is no solution. So what you find out that solving these multi-step inequalities, it's exactly the same as solving these multi-step equations. Exactly the same. We just have to think about one last little thing. And that thing is, if my coefficient is negative, my inequality is going to flip. Until next time.